Hello, this is Jennifer Martinez. What is a function? Do you know? Well, that's what we're going to talk about in section 1.1. And let's start with the definition. A function, it says here, is a rule that takes numbers as inputs and assigns each input to exactly one number as the output. We say the output is a function of the input. Say you have a calculator and you want to input a number, just one number, and then maybe you square it, or you take the square root, or you multiply it by 2. The input is the number that you put in, and the output is the answer that you get back. And you hopefully, there's exactly one answer. You don't want the calculator flashing on you. There are 4 main ways of describing a function: with a formula, with a table of values, with a graph, or with words. It's important to be able to see the connections between these different kinds of descriptions. So let's look at this by a couple of examples. Before I do example 1, I want to start with a slightly easier example. Natalie. Natalie is 4 years older than Ben. Write a formula for Natalie's age in terms of Ben's age. So we're going to practice the first one, writing a formula. By the way, these are words, so from words we're going to compare those two. So if I'm going to write a formula, it's easiest if I had some letters, which we call variables. Variables in a word problem are letters, a lot of times X, but it could be any letter, that represents an unknown quantity or a quantity that changes over time. Well, Natalie, we don't know her age, so she would be considered a variable. And also Ben, we don't know his age as well. And they're unknown and they change over time. So let's go ahead and do that. So I'm going to choose N and B. I'm going to let N equal Natalie's age and B equal Ben's age. And then I'm going to come up with a formula for Natalie's age. So what is Natalie's age? Well, N stands for Natalie's age, so I'm going to start with N equals. And what do we know Natalie is? Oh, she's 4 years older, so 4 plus for older than Ben. That makes sense, because if Ben is 10, and Natalie is 4 years older, then she would be 14. Instead of Ben, I'm going to write B. Here is my formula. So I wrote a formula for Natalie's age in terms of Ben's age. And you can see this would be an example of a function. We can also make a table and a graph. So let's go ahead and try that for this second one. Example 1. Let P be the population of a town and T be the number of years after 2000. Let's describe P as a function of T 4 ways. So first they're starting with words, just like I did. The population was 5,000 in 2000. That's when T was 0, by the way. And it grew by 250 people every year. But instead of going straight to a formula, they went to a table. So let's go ahead and see if we can fill out this table. What is the population with T equals 0? Well, it's telling me right here that it was 5,000. That's easy. By the way, that's in the year 2000. And T equals 0. So T is the number of years after 2000. The reason they didn't put 2000 here is because they wanted the T to be small. So a lot of times when they do these word problems with time, and they start in a specific year, right? Or you can say number of years after any year that you want, but wherever you want to start, and then you start from that spot. Okay, it grew by 250 people every year. So how are we going to figure out in 1 year? So if it grew by 250, we're going to take 5,000, we're going to add 250. So I got that by 5,000 plus 250. The second one. Well, if it grew by 250 a year, then this would be 5,000, another 250. You would get that. You can get that by taking this and adding 250 again, or what I'm going to do is say 250 times 2, right? Because now we're in 2 years and we use that 2. So if I input a 2, if I multiply it by 250, I get 500, and then I add that extra 5,000. And we can continue on this way. This one would be 5,750. So if I keep on adding 250 every year, but you can see this last one. Let's see if this works. 250 times 5. So if you take 250 times 5, you would get 1,250. And that would be 6,250. You can check your calculator to see if that works. Notice for each input, there is exactly one output. That means that this is a function. Okay, can we graph this? When you graph a function, the input is always going to be on the horizontal axis, and the output is always going to be on the vertical axis. So the input is easy. It is t. You're just going to count by 5. I like to try to evenly space them. Now the output's a little tougher because we need to get to 6,000 somehow. So I'm going to count by 1,000. Don't want to count by 1. So I counted by 1,000. I decided to skip one, so this would be really 500, right? I did a tick mark every 500 instead of every 250. And if I started plugging in, 0 would be 5,000. I'm going to skip 1 for a minute and go to 2. 2 is 550. So having grid paper is a little bit easier. I know they didn't give us grid for there, but 2 is about 550 right there. Draw little lines. 1 is halfway between that. I'll skip 3. Go to 4 is 6,000. You don't have to graph every single point. Just need to get a shape here. 4 is like 6,000. And that gives us enough. You could go to 5, which is halfway in between. You could do the 3. It's just a good idea to graph enough points so you can see the shape of your curve. In this case, it's a line. And it does go on forever there. This was the input. I didn't mention this earlier. The output, we talked about the output, but I never wrote the letter there. That is P. So the input is always on the horizontal. On the vertical is always the output, as I said at the beginning of the graph. So now we want to come up with a formula. So what is the formula? So far I've done the table, we've done a graph, they gave us words, so now we're going to do a formula. And the formula is a little bit tougher than the last example, but we can still do it. So we're going to start with 5,000. So I'm going to put a 5,000 here. I'm going to add a GRU, so it's adding, by 250 people every year. So I'm going to write 250. I realized when it was 1, I just put times 1. 2 was times 2. 5 was times 5. So if I put a t here, put the input, I will get this formula. You can see if I plug in a 5, I will get this one. Plug in a 2, plug in a 1. This is the formula for our function. Again, it is a function. Let's go back to the definition again. The function is a rule. This is a rule that takes an input. So these are inputs and inputs, and assigns exactly one output to each input. So this one just had 1, this one had 1, and so forth. We can describe a function using a formula. We did here. A table, a graph, or with words, which is what they gave us. So now let's look at function notation. This is a new notation for our function. What is a function notation? Y equals f of x. Now, f does not mean multiplication. It's just a notation. X is called the input, or sometimes known as the independent variable. We'll explain why in a second. Y is the output, or the dependent variable. If we go back to our first example, the input was the B, and the output was Natalie's age, as it's written here. So whatever is in is equal, that's usually considered the output. The B is the input. So if I was to graph this or make a table, I would make B first and then in, because it would be easier just to say, okay, when B is 1, how old is Natalie? When B is 2, how old is Natalie? And so forth. So B is called the input. They call that independent because it really doesn't matter how old Ben is. But once you plug in an input, it's dependent because Natalie's age depends on Ben. Same with this one. The input was the T, the output was the P. Didn't matter what year it was. I just plug in anything. 0, 1, 2, 3, 4. It seems random. But once you plug in that input, the output depends on the input. F is the name of the function. It is not a variable and it doesn't stand for a number. Very confusing, I know. F and X are not being multiplied. As I said before, f of x stands for the output, the whole thing. When x is the input, f of x is read aloud f of x. In the example with P and T, our example 1, P, well, let's start with independent. Independent is T, and the output was P, right? The independent was T, the output was the P. And so you need another letter for the name. So let's say G is the name of the function. You could call it P. They sometimes do that, but first of all, let's just call it G, since that's what they're doing, which gives P as the output. With the variables you could write, so what you would write here, P is the output, G is the name, and T is the input. So this one is the output, the X is the input, and the F is just the name. As a formula, you could call this G of T, and instead of writing a P here, you could write what the formula is. It was 5,000 plus 250 T. And again, G can be any name that you would like. So you could have called it F. You could have even, like I said earlier, called it P. If you called it P, it would have looked like this, but it would still have been equal to P. So you can use that twice. Sometimes they do that. So now let's write the first 3 columns of the table using function notation. So the table, if you remember, was up here. I'm just going to copy and paste this down here so we don't have to go back and forth. So for instance, if you want to use this notation, let's use the G of T equals P notation. We could say P is equal to G of T. Let's use that notation. So the first column, when the T is 0 and the P is 5,000, you would have 5,000 is equal to G of 0. So that means that the T would be 0 and the P would be 5,000. Or the second one, 5,250 would equal G of 1. Or the third column here, 5,500 would equal G of 2.